All right, good morning. Today we're going to look at a few practice problems and some more homework. Okay, so what we're going to look at first is practice problems set number 1. Here's the problem. Gary starts with $15 and Gada starts with $0. On each day that goes by, they each get $1 extra. In how many days will Gary have twice as much money as Gada? All right, do you understand the problem?
Yeah.
How much money does Gary start out with?
0. No, 15.
Gary starts out with 15. How much does Gada start out with?
0.
And what happens every day?
They get $1.
They get $1 more. And we're trying to figure out how many days will Gary have twice as much money as Gada. Okay? So Gary starts with 15. Oh, shoot, sorry. Can we still see on the screen? Yep. Whoa, a little fuzzy. Okay. So Gary, 15, Gada, 0. So this is at the beginning at time 0. What happens at day 1?
16 and 1.
16 and 1. What happens on day 2?
17 and 0. 17 and 2.
17 and 2. Okay. Okay. So we're trying to, how much money does Gary have on each day? On day X, how much does Gary have?
On each day.
On day X, how much does Gary have?
Which is day X?
So if X days go by, how much money does Gary have?
He always has 15 more than Gada.
Okay, but how much does he have on a particular day? How do you figure it out? If X days go by, how much extra money does Gary get?
Gary gets X extra money.
X extra money. On one day later, he had 16, 1 more, 2 days later. So on day X, Gary has how much? 15 plus what?
15 plus X.
Plus X. So 15 plus X. And on day X, how much money does Gada have?
He has 0 plus X.
0 plus X. That's exactly right. And we're trying to figure out how many days does it take for Gary to have twice as much money as Gada. Okay, so we're trying to solve the equation. Twice as much means we multiply Gada's money by 2.
Yeah.
Right?
Yeah.
Okay, so 2 times Gada equals Gary. So 2 times, what's 0 plus X equal?
X.
Just X. So 2 times X equals 15 plus X is the equation we're trying to solve.
Yeah, and what is X?
What is X? So if 2 times X equals 15 plus X. Okay, I'm going to erase this stuff and pretend we're going on to the next page so we have a little bit more room. So 2X 15 plus X. Okay? Do you have an idea of what you need to do to solve this equation?
Well, you can just get rid of the 2X. You can get rid of the X's.
Okay, if you get rid of an X from one side of the equation, what happens? How do you get rid of one X?
You can just move it to the other side.
Okay, which X do you want to move to the other side?
Well, one of the 2X. Or you could just move this X to the other side.
Okay, and how do you move that X to the other side? Do you remember how to do that?
Subtract.
You subtract. You subtract an X from both sides. Minus X, minus X. So what's X minus X?
0.
0. So this side of the equation over here just becomes, what, 15 plus X minus X, which equals?
0. So it's the same as X plus 15.
Well, so the 15 stays the same, right?
Yeah.
And the X plus X minus X. So what happens to this side of the equation?
Well, it's just a 15.
It's just 15. And what's 2X minus X?
X.
X.
So X equals 15.
So we know that X equals 15. So if Gary starts with 15 and gets $1 every day, 15 days later he's going to have $30. So Gary has 30. And how much does Gada have if he starts out with 0 and gets $1 every day for 15 days?
15.
Okay, and is 30 equal to 15 times 2?
Yeah.
Okay, great. We figured that one out. Okay, the one extra thing I need you to check for this homework problem I'm going to assign you is to see if you know how to subtract dates. So just a real quick problem. So let's say 1985 minus 1971. Okay, I just made that up real quick. So how do you do that subtraction problem?
Well, this is 0.
Okay, what is that? That's 1,000?
Minus 1,000 is 0.
Okay, so write that down. 0.
And 900 minus 900 is 0.
Okay.
80 minus 70 is 10.
Yeah.
And 5 minus 1 is 4.
Okay, so what is 1985 minus 1971?
14.
14. Very good.
0, 0, 14.
0, 0, 14. Okay. So the homework problem you have for this one is Olympiad 24 problem number 1. Okay, so now you know how to do everything in that problem. Olympiad 24 problem number 1. Okay, let's go on to the next problem. Okay, here's the next problem. This is going to be a short little lecture on perimeter and then some problems about perimeter. So, have you ever heard the word perimeter before?
Yeah.
What does it mean?
Well, it means the outline of something.
Okay, it means how far is it around the outside edge of something. So
it's like the circumference.
It's similar to the circumference. So let's say I had a little square and I told you that the square has 3 inches on each. Oops. Okay, so this square is 3 inches on each side. What's the perimeter?
Perimeter is 3 times 6. Because every cube has 6 sides.
Well, but pretend this is just a square, not a cube.
Then it's 3 times 4, which is 12.
It's 3 times 4, which is 12. So sorry, I know it looks like a cube, and I know it is actually a cube, but we're just going to pretend it's a square.
Then you can just draw a square.
So the perimeter
Then you flatten it out.
equals 3 times 4, which is 12 inches.
That's better.
Okay, right. Flatten it out, squish it.
Oh, yeah.
Okay, so now let's do some trickier perimeter problems. So we're going to say the same thing. These red squares have 3 inches on each side. Okay. But now we're going to make out of these squares a bigger square.
Yeah.
Okay, so now suppose we make a gigantic square, but all of the little squares have 3 inches on each side.
And
So,
it has to be flattened out.
okay, yeah, flatten it out. Well, that's not really flattening it out.
That's turning into a rectangle.
Yeah,
We don't have enough room.
right. Okay, so just pretend this is a flat square. Okay?
Yeah.
Here, we can erase that. All right, and each little square is 3 inches on each side. So how do we figure out what the perimeter of the big square is?
You gotta figure out how many little squares make it up.
Well, when you're trying to figure out what the perimeter is, what are you trying to actually figure out?
How are you trying to figure out how long it is?
How long it is all the way around the outside.
Yeah.
Okay, so you know each little square is 3 inches on each side.
Yeah.
So how big is one of the sides of the big square?
6 inches.
How did you figure that out?
It's 3 inches on each side.
3 inches, each one of these squares is 3 inches on each side.
And that's 4 sides.
Well, the big square has 4 sides.
Yeah,
So we have to figure out how long each one of these sides is.
9 inches.
Okay, how did you figure that out?
3 times 3.
Okay, why did you do 3 times 3?
Because that equals 9.
Yes, I know that.
But to figure out how many sides it is.
How long the side is. So why 3 inches, why did you do 3 inches times 3?
It equals 9.
Why did you do 3 inches times 3? Why were you multiplying by 3?
Well, multiplying what?
Why did you need to multiply by 3?
So that's how many cubes are on each side.
Right, that's how many cubes are on each side. So there's 3 inches. There's 3 inches. So this side's 9. How long is this side?
That would be another 9.
It'd be another 9. How long is this side?
9.
9.
And a 9.
And a 9.
So it's 9 times 4, which is 36.
Okay, 9 times 4, which is 36. Okay. So now I'm going to give you one tricky problem.
A really tricky problem?
Yeah. Suppose I have a square that's made out of 2 blocks like that. So this is another square.
A square. So you flatten it out.
Okay. So the big square is, let's say, 10 inches.
On each side.
Okay. So let's draw that.
10 times 4.
10, 10, 10. But now the question is, if I cut it in half, okay, so I take half of that square away, what's the perimeter of the smaller rectangle? Okay. So I take this half and I put it, let's say I put it over here. I didn't draw this out very well. But now we're just trying to figure out.
Well, this is half of that, so that's gonna be 210. So it's gonna be 30.
Okay, how did you figure that out?
Well, because I figured out that this side, the front side and the back side, is half of these longer sides.
Okay, and how long are the longer sides?
10 inches, so
10.
these must be 5 inches.
10, 10. I hope this is on the screen. Okay, it barely is. 10, 10, 5, 5. So what's the new perimeter?
The perimeter is 30.
30. Okay, and that shows you something interesting, that you have to calculate the new perimeter. Because what was the perimeter of the original square?
40.
40. And when we took half of it away, what was the perimeter?
30.
Is 30 half of 40?
No.
No. So perimeters don't work the same way that other things work. When you cut the picture in half, it's not necessarily that the perimeter is half. It's not necessarily true. Okay, so watching this video, you now have enough information to do Olympiad 24, problem number 2. Okay.
Right.
All right. Very good. Good job this morning. Those were fun problems, weren't
Yeah.
they?